Okay? So we've got this roller coaster, and we want to find the equation for it. It's the main point. And then you're going to do a write-up of this whole thing. So when I have a graph like this, tell me again, guys, what is the easiest way to find it? Roots. Okay. So we know there is a root where? Somewhere here. We agree? There's a root somewhere in here. There's a root somewhere here. And there's a root somewhere here. This has a multiplicity of how much?
2.
This has a multiplicity of?
1.
And this has a multiplicity of?
1.
Okay. So, we know it's kind of like our quiz, where you're going to have to find A. All right? So, the next thing I want you guys to think about is how this equation is going to look. We know we're going to have y equals something. We're going to have an A. We don't know what that is yet, right? We have x minus something, because this is positive, squared, times x minus something, times x minus something. Have you guys ever been on a roller coaster where you had to climb up something, like climb up 75 feet worth of stairs to get on it to start at the top of the hill? Is that normal?
No.
Don't you usually just climb up a couple stairs, get on it, and it starts off and then climbs up the hill next? Like the Millennium Force, right? You start at the bottom and it climbs up that huge hill first in Cedar Point, and then goes down. Okay. Right, but you get in line, it climbs up the hill, goes click, 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 click. Okay? All right. So would it make sense that this would come down somewhere over here? All right. So it looks like this is a 2, 3, 4 equation degree, but I'm telling you it's a 5. Okay? This is something I played with this equation to come up with the answer over and over again. And then I'm like, wait, this doesn't look like it's going straight through there. That looks like it's starting to turn. I bet that's a hill. So I bet it comes down. All right. If we decided this was my max, this point over here and this point over here would have to be equal on either side, correct?
Correct.
Okay? So we're going to, and this is going to have to be a positive or a negative over here. Negative, so that means I'm going to have x plus that number, right? I would make these two numbers right here the same. Okay. So you kind of have your setup. Everybody's going to be a little bit different because you have to pick kind of what your roots are going to be. Now here's the next step. Yes. We don't know. We'll just assume it goes down. We don't really care what happens over there anyways. Okay, because this is the part that they want us to design. Okay. So, how do I find my A? What do you guys do to find your A? You plug in a what? We don't plug in a root. We plug in a point. What point might be easiest on here? When is x going to be 0?
75.
Okay, that's probably not 75 though, guys. 0 something. This goes up 0 to 25, 25 to 50, 50 to 75, and it doesn't look it touches 75. It looks like it's a little bit under. So whatever that number is, you're going to plug them in for x and y. Once you plug in your roots, first step, find roots. You get to pick the numbers that you think are here. 1, 2, 3, and this one over here. Okay? So you're going to pick them. It kind of shows you on there, you're approximating. 2, plug in a point. I would do 0 for x, whatever you think that y value is. That's going to help you find your A. Okay, step 4. Graph your equation. And you're going to have to make some adjustments to your window. Okay? Then how am I going to check that my graph on my graphing calculator is the same or super close to this picture? So if I pull up a graph, how would I know that these things, that it was the same? What would be a key thing to look on here? Maybe I could check what?
Infinities.
So infinities, you should have one pointing up and one pointing down. Your end behaviors is what you're saying. Okay? But that should be pretty clear if we have a, 5 root problem. But we want to check our maxes and mins. You know approximately what this max is. You know approximately what this min is. Are they the same or close when you put your graph, your new equation in the graphing? If they're not, you might have to go back and change your roots a little bit and see if you can get something closer. Then you can find your new A if you adjust them. Okay? So, your goal in class, after you find your max and mins, let's say you get a good match. I don't know anybody who didn't have to adjust a little bit, who got them right off the bat. So you might have to adjust. You're going to graph it on paper. You're basically copying what's on your calculator onto your graph paper. Okay? Once you have that, then you can work on your write-up. And you're literally going to tell me each of these steps that you went through and how you got your answer. First, you're going to tell me what the problem is. Then you're going to tell me how you found your roots. Then you're going to plug in a point. I recommend the y-intercept. Okay? You're going to find A. You're going to graph that equation. Adjust your window. Check your max and mins. See if you need to adjust your roots. Get a good match. Graph it on paper. Okay? You're going to explain all of that in your write-up. The write-up is due at the beginning of the hour tomorrow. You have the rest of the hour to find this. Your write-up I would do as homework. Okay? Of course, if you get a decent equation but you're not quite happy with it and you need to adjust it at home, again, I suggest going to Google, typing in Desmos graphing calculator. It's one of the best graphing calculators they have. It might be better than your calculator. The way it shows up, because it's like a bigger window and all of that. Okay? And I would keep working on that. This is due at the beginning of the hour tomorrow. I would try to get as close to these 7 steps done in class as you can. And I'm going to leave them up on the board. Okay? If you're having trouble with something, let me know. But I am going to stop recording